drawing my first angle. It goes from here, whoa, to over here somewhere. It's 118.816. Now what I need is an angle that goes from here to over here that has the same reference angle. So that this angle and this angle would be the same. Because that's what makes them cosine. Because we know we just find the reference angle to find, adjacent over hypotenuse and whatnot. So for the blue angle, how do I find the reference angle?
180 minus 118.
Yeah, very good. 118.816. So that's this angle. It's 61.184. It's hard to see. 184. So that means this angle down here is also 61.184. But I want to find the purple angle. All I found is the little green angle. The little green angle is just that one. How do I find all the way the purple angle?
So you add all those together?
Yeah, you add, yeah. You could absolutely add all those together. Meaning I could add 118.16, 61.184 plus 61.184, or
just 180 and then 60.
180 plus 61.184. So there's the other angle. I want to skip ahead and do some radians. So turn to the next page. I'll come back if we have time. But it's pretty much the same process over and over again. This is the same thing. Solve for each of the trig equations. But this time, theta is in between 0 and 2 pi. So that means we're in radians. Which means you need to change your mode on your calculator back to radians. Okay, so before I plug it in, this time let's just look at it and let's determine which quadrant this cosine would be in. Which quadrants?
The second.
Okay.
And the third.
Remember, it's all students take calculus, so it's not where they're all positive. Yes, ma'am. Absolutely. Got that. And it's not this one down here because cosine's positive down there. So it's 2 and 3. So now let's plug this in. How are we going to find theta?
Inverse cosine.
Yep, inverse cosine of negative 0.9848. Don't forget it's cosine. 48. And make sure you changed it to radians. What do you get?
2.967.
Yeah. Which seems, but remember this is in radians. So we're going to draw this down here in terms of radians with the decimals so that we can figure out what it is. So if this was 0, remember 90 degrees was pi over 2.
Oh, this is like the unit circle thing?
Mm-hmm. But I'm not going to draw the unit circle. I'm just labeling the axes. Just like if this was degrees, I would have made this 90, this 180. I'm just using radians. Okay, so pi over 2. I'm going to type in my calculator. Pi divided by 2. That's the decimal 1.571 approximately. The pi button is right above the division button. You just have to hit second and the caret key. Does anybody remember in radians what 180 is?
Is it 2? No, it's just pi.
It's just pi. Yeah.
That's what it is.
So what is pi?
3.14.
3.14. I think it's 159. So it's, yeah. So it's 3.142 approximately. This one down here is 3 pi over 2, which is approximately 3 times pi divided by 2, should be 4.712. You got it, Sean? Okay, thank you. So 2.967, we can see, is definitely in the second quadrant. All right, because it's between 1.571 and 3.142. I'm going to draw it over here. Stand up here. I want also the one this purple one. What's it gonna take for me to figure out this purple angle?
You add pi
Pi plus what?
plus the pi reference.
Yes, plus the reference angle, but that's good. So we just got to find this little reference angle right here, and that's going to be this same reference angle right here, and then I add it to pi, which you can use the decimal or the pi button down there. So to find, we'll call it the reference angle, what do we do to find that green angle?
Is it just 180 minus 2.
Yes, except for instead of 180, now we're using what?
Oh.
Pi. Yeah, same thing. It's just in radians now. So yeah, pi minus 2.967. Second pi minus 2.967. I got 0.175. So that is also that other angle. So now, Cameron, how'd you say I found the purple angle?
Add pi to it.
Add pi, yeah, to that one. Because it's pi plus this little bit. Pi plus 0.175. $3.317. 317. Here's one of them, and here's the other one. And you can put radians behind it or not. I just did that so you'd remember it was in radians.
Thanks, Rasher.
You may. Questions? Okay, so we're in radians. So if we haven't done it yet, back up. Change your calculator to radians, because on this next page it is in radians. Good, good, good. And this one is the cotangent is equal to this. Well, we don't have a cotangent button. So what do we need to do?
What's it the opposite?
Yeah, what's the reciprocal?
It's opposite.
Tangent, yes. So the tangent of theta is equal to what?
Would it be like 1 over?
Yes.
I thought that was too simple.
Nope. So to find theta, I just do the inverse tangent of 1 divided by 5.671. I should have found the quadrants first, but that's okay. What'd you guys get?
0.175.